It's midnight and I'm scrolling Cosmos videos on YouTube.
This is ISS Mimic, an articulating scale model replica of the International Space Station that's powered by real data streaming live from the real thing.
A small scale model of International Space Station brought to life by live telemetry data controlling its solar panels. So I thought, what if I create an entire digital twin of ISS and also add some additional features like its rotation around the Earth? I will try to calculate that. Before getting into nitty-gritty details, let me give you a quick overview of what the project is all about and what you can expect to see as we progress. The project is structured in a way where we have to fetch API. The API is provided by NASA and it is open sourced. A canvas to render model and CSS for styling. We'll break down the ISS model into its distinct components like its solar panels, compartments, and other structural elements. These components will be programmed to respond dynamically to telemetry data. Think of it like a living, breathing virtual space station. Let's talk about few challenges. Mesh selection. We want something which indicates selected mesh. We can do that by changing the material of the selected mesh, but there is a problem when we try to revert the selected mesh. To solve that, I have written a function. We have to store previous mesh and its original material so that when we click on some other mesh, we should be able to revert the material of previously clicked mesh. Handle mesh click takes mesh as an input and checks if it is selected or not. If yes, then reverts the previously selected, and if the clicked mesh is the same as the previously selected one, then unselects it by setting null. If the clicked mesh is not the same as previously selected one, update the mesh, store the current material, finally apply the material which indicates selected. Now comes camera movements. You want to get a closer look at a specific component like solar panel or a module. You may have noticed that sometimes the camera moves a bit too abruptly or even pass through objects. This can be disorienting and make it challenging to focus on the details we are interested in. To solve this problem and provide a smoother and a more intuitive user experience, I have created a function. This function allows us to smoothly move the camera to a selected mesh, such as solar panel or a module. Let's break down how it works. Target position and camera position calculation. When a user clicks on a specific mesh, the function calculates the target position based on the mesh's absolute position. This is where we want the camera to focus. Then, using the mesh face normals, we calculate the new camera position in a way that maintains a comfortable distance from the target. This helps us to avoid camera clipping through objects. Creating a smooth animation. To ensure a smooth transition, we utilize animation techniques. We create an easing function that adds a natural acceleration and deceleration to the movement. This makes the camera movement more organic and less abrupt. Then we set up a position animation with keyframes that gradually move the camera from its current position to the calculated camera position. Applying the animation. We attach the animation to the camera and initiate it using Babylon.js animation system. As a result, the camera gracefully glides towards the target mesh, giving you a comfortable and visually pleasing experience. So whether you are a developer, a space enthusiast, or just someone curious about how these technologies came together, this series is for you. So make sure you hit the subscribe button, turn on notifications so that you will get notified as we progress. Thanks for tuning in, and I will see you in the next one.